Hey everyone, Mr. Andrew here. Today I wanted to talk about how we count atoms in a chemical formula. So let's say we have the chemical formula for water. The chemical formula is H2O. Now, you may notice this number right here. This number is called a subscript, and the subscript tells us how many atoms of a particular type we have in a chemical formula. Now, the subscript only applies to the element that comes directly before it. So in this case, this 2 right here in the middle, this tells us that there are 2 hydrogens in this molecule. Now, we may notice that oxygen doesn't have a subscript. There's nothing written. If there's no subscript written, then the subscript is implied to be a 1. So, if we read this formula, we can see that there is 1 oxygen and 2 hydrogens. And if we were to draw this molecule, it would look something like this. There's an oxygen right here, okay? And it's bonded to 1 hydrogen and another hydrogen, okay? So we can see there's 2 hydrogens and 1 oxygen. But sometimes we might see other numbers. In front of a chemical equation or a chemical formula, we can see a big number, something like this 2 right here. Okay? This number is called a coefficient. And coefficients tell us how many copies of a particular molecule we have. So, this coefficient 2 tells us that there are 2 copies of this water molecule. So now our formula is telling us that there are 2 molecules that are identical. So let's just draw another one right here. Now, if we were to count these up, right, let's say we didn't want to draw the molecules out, we would start by just listing what elements we have. I'm going to do that in the bottom left corner here. So we have hydrogen and oxygen. In the formula, there are 2 hydrogens. We're getting that from the subscript. And there's 1 oxygen. And then we're going to multiply both of these by 2. Okay, so this row right here is from the subscript, and this row right here is from the coefficient. And so if we count these out, 2 times 2, that's 4. 1 times 2, that's 2. So we have 4 hydrogens. 1, 2, 3, 4. And we have 2 oxygens. 1, 2. Okay? Now we can use this strategy to count up all different kinds of formulas. So let's look at one that's maybe a little bit more complicated. Okay, let's look at Mg3PO4 2. Now this one's actually quite a bit more challenging because this one has parentheses in it. But we can count them up using the exact same strategy that I used on the last one. First, I'm going to list out what elements I've got. I've got magnesium, I've got phosphorus, and I've got oxygen. Okay. Now, let's take care of magnesium first. So magnesium has a subscript of 3. Okay. Phosphorus and oxygen are inside the parentheses. So, because we have an additional subscript outside of the parentheses, what this tells us is there are two copies from this subscript. There are two copies of everything in the parentheses. So inside the parentheses, there's one phosphorus, but because we have two copies of that, there's two. And inside the parentheses, there's 4 oxygens, but because we have two copies of that, there's 8. So in this molecule, we have 3 magnesiums, 2 phosphorus, and 8 oxygen. Let's try one more. Let's do Al2 SO4 3. So right here, we have aluminum, sulfur, and oxygen. But this time, I'm going to make it a little bit more tricky. I'm going to add a coefficient, and let's call it a 5. Okay? So I'm going to total it up the same way. I'm going to start by listing my elements. I have aluminum, sulfur, and oxygen. Let's count up how many we have. We have 2 aluminums. We have 1 sulfur in the parentheses, but we have 3 copies of that from this 3 right here. So it's 3 sulfurs. We have 4 oxygens in the parentheses, and there's 3 copies of that, so that's 12. So again, these are from the subscripts. And now I'm going to multiply all of these by 5. This is from our coefficient. So 2 times 5, that's 10. 3 times 5, that's 15. 12 times 5, that's 60. So we have 10 aluminums, we have 15 sulfurs, and we have 60 oxygens.